So വേറൊരു കൺസെപ്റ്റാണ് മാക്സിമൽ എലമെന്റ്. So let x less than or equal to be a poset, and small m is a maximal element. Of x if, sorry, we can give it a model. So let this be a poset and A is a subset of x. Then M, an element of A, is a maximal element if for x an element of A, M less than or equal to x implies M is equal to x. X is a partial ordered set, x less than or equal to is a partial ordered set, and A is a subset of x, and M is an element of A. Then we say that it is a maximal element. M is a maximal element of A if for x element of A, M less than or equal to A implies. In other words, M an element of A is a maximal element of A if there is no element there is no element x in A, M less than x. There is no element strictly greater than that. An element of a subset A of a partial ordered set is, say M is a maximal element if there is no element strictly larger than that. The same thing can also be written this way. That is, for every element x of A, M less than or equal to x implies M is equal to x. These two things are one and the same. Such elements are called maximal elements. Not that there is a difference between maximum element and maximum element. If M is a maximum element, that means every element is less than or equal to that. And M is a maximal element if there is no element strictly greater than that. These two are different concepts. I will illustrate this with an example. You take a set X containing some sets, that is empty set A, B, C, AB, AC, BC. This is a set. And the relation is subset of. This is a partial ordered set. If you take any collection of sets, set inclusion will be a partial order on that, because set inclusion is reflexive and symmetric and transitive. So this is a poset. That is This is a set. Now you consider X. Here you can see that for AB, the set AB is an element of X. Is an element of X. Clearly, this is a maximal element. Why? There is no element here strictly larger than this. So this is a maximal element. Similarly, AC is also a maximal element because there is no element strictly larger than AC. BC is also a maximal element. So in fact, these three are maximal elements of the same set. And none of them is a maximum element. For that to be a maximum element, every set should be a subset of that set. That is not possible. Here, if you take AB, singleton C is not a subset of this. If you take AC, singleton B is not a subset of this. And if you take BC, singleton A is not a subset of this. So there is no maximum element, there is no largest element, but there are three maximal elements. And if you delete the empty set from this collection, then you can see that singleton A, singleton B and singleton C are minimal elements. And how minimal elements are defined? You can just change minimal element. Suppose this is a partial poset and A is subset, M is a minimal element of A if X less than or equal to M implies M is equal to X. Or in other words, is a minimal element of A if there exists no element which is less than, strictly less than. So minimum element and minimal element are different concepts. A set can contain at most one minimum element, whereas it can contain several, possibly infinite number of minimal elements. A set, if a maximum element exists, that will be a maximal element also. If that is, if there is a largest element in a set, a subset of a partial order set, that will become a maximal element. But a maximal element need not be the largest element. Similarly, a minimum element, if it exists, is a minimal element, whereas a minimal element need not be a minimum element or the smallest element. For linearly ordered sets, these two concepts coincide. For a linearly ordered set, an element is, if an element is a maximum element, it is a maximal element. If it is a maximal element, it is a maximal element. Similarly, if it is a minimum element, it is a minimal element, and if it is a minimal element, there is a minimum element. So these two, the difference will be only in the case of partial order sets which are not linearly ordered. If a partially ordered set contains only one element, that element will be both minimal and maximal. There will be both minimum element as well as maximal. Now let x less than or equal to be a poset, and A is a subset of X. Then A is an upper bound of A, an element of X, is an upper bound of A if X is less than or equal to A for every X element of X. A is a subset of a partially ordered set X less than or equal to, and small a is an element of, say, capital A. Then it is an upper bound of